Landing ship, tank, or tank landing ship, is the naval designation for vessels created during World War II to support amphibious operations by carrying vehicles, cargo, and landing troops directly onto an unimproved shore. The first tank landing ships were built to British requirements by converting existing ships. Then the British and US collaborated upon a joint design. Over 1,000 LSTs were laid down in the United States during World War II for use by the Allies. 80 more were built in the United Kingdom and Canada. LST Mk.1. The British evacuation from Dunkirk in 1940 demonstrated to the Admiralty that the Allies needed relatively large, ocean-going ships that could handle shore-to-shore delivery of tanks and other vehicles in amphibious assaults upon the continent of Europe. As an interim measure, 4,000 to 4,800 GRT tankers built to pass over the restrictive bars of Lake Maracaibo, Venezuela, were selected for conversion because of the shallow draft. Doors and ramps were added to these ships, which became the first tank landing ships, LST HMS Misoa, Tasahera and Bachaquero. They later proved the worth during the invasion of Algeria in 1942, but the bluff bows made for inadequate speed and pointed out the need for an all-new design incorporating a sleeker hull. The first purpose-built LST design was HMS Boxer. It was a scaled-down design from ideas penned by Prime Minister Winston Churchill, in order that it could carry 13 Churchill infantry tanks, 27 other vehicles and nearly 200 men at a speed of 18 knots. It could not have a shallow draft sufficient for easy unloading. As a result, each of the three ordered in March 1941 had a very long ramp stowed behind the boat doors. The three ships were converted to fighter direction ships for the invasion of Normandy. The U.S. were to build 7 LST, but in light of the problems with the design and progress with the LCT Mark II, the plans were cancelled. Construction of the LCTs took until 1943 and the first US LCT was launched before them. LST Mk.2. Development. At the first meeting at the Atlantic Conference in Argentia, Newfoundland, in August 1941, President Franklin D. Roosevelt and Prime Minister Winston Churchill confirmed the Admiralty's views. In November 1941, a small delegation from the Admiralty arrived in the United States to pool ideas with the United States Navy's Bureau of Ships with regard to development of ships and the possibility of building further boxes in the U.S. During this meeting, it was decided that the Bureau of Ships would design these vessels. As with the standing agreement, these ships would be built by the U.S. of British shipyards could concentrate on building vessels for the Royal Navy. The specifications called for vessels capable of crossing the Atlantic, and the original title given to them was Atlantic Tank Landing Craft. Calling a vessel 300 feet long aircraft was considered a misnomer, and the type was rechristened Landing Ship, Tank, or LST. The LST design incorporated elements of the first British LCTs from the designer, Sir Roland Baker, who was part of the British delegation. One of the elements provided for sufficient buoyancy in the ship's sidewalls so that they would float the ship even when the tank deck was flooded. The LST gave up the speed of HMS Boxer at only 10 knots, but carried a similar load while drawing only 3 feet forward when beaching. Design. Within a few days, John C. Niedermayer of the Bureau of Ships sketched out an awkward-looking ship that proved to be the basic design for the more than 1,000 LST that were built during World War II. To meet the conflicting requirements of deep draft for ocean travel and shallow draft for beaching. The ship was designed with a large ballast system that could be filled for ocean passage and pumped out for beaching operations. An anchor and mechanical winch system also aided in the ship's ability to pull itself off the beach. The rough sketch was sent to Britain on the 5th of November 1941 and accepted immediately. The Admiralty then requested that the United States build 200 LST for the Royal Navy under the terms of Lend-Lease. The preliminary plans initially called for an LST 280 feet in length, but, in January 1942, the Bureau of Ships discarded these drawings in favor of specifications for a ship 290 feet long. Within a month, final working plans were developed that further stretched the overall length to 328 feet and called for a 50-foot beam and a minimum draft of 3.8 feet. This scheme distributed the ship's weight over a greater area, enabling her to ride higher in the water when in landing trim. The LST could carry a 2,100-ton load of tanks and vehicles. The larger dimensions also permitted the designers to increase the width of the bow door opening and ramp from 12 to 14 feet in order for it to be able to accommodate most Allied vehicles. As the dimensions and weight of the LST increased, steel plating thickness increased from 0.25 inch to 0.375 inch on the deck and sides, with 1 inch thick plating under the bow. By January 1942, the first scale model of the LST had been built and was undergoing tests at the David Taylor Model Basin in Washington, D.C. Provisions were made for the satisfactory ventilation of the tank space while the tank motors were running, and an elevator was provided to lower vehicles from the main deck to the tank deck for disembarking. In April 1942, a mock-up of the well deck of an LST was constructed at Fort Knox, Kentucky to resolve the problem of ventilation within the LST well deck. The interior of the building was constructed to duplicate all the features found within an actual LST, being the home to the Armored Force Board. Fort Knox supplied tanks to run on the inside, while naval architects developed a ventilation system capable of evacuating the well deck of harmful gases. Testing was completed in 3 months. This historic building remains at Fort Knox today. Early LST operations required overcoming the 18th-century language of the Articles for the government of the United States Navy. He who doth suffer his ships to founder on rocks and shoals shall be punished. There were some tense moments of concept testing at Quonset, Rhode Island, in early 1943 when designer Needham Air encouraged the commanding officer of the first U.S. LST to drive his ship onto the beach at full speed of 10 knots. Production in 3 separate acts dated the 6th of February 1942, the 26th of May 1943, and the 17th of December 1943. Congress provided the authority for the construction of LSTs along with a host of other auxiliaries, destroyer escorts, and assorted landing craft. The enormous building program quickly gathered momentum. Such a high priority was assigned to the construction of LSTs that the previously laid keel of an aircraft carrier was hastily removed to make room for several LSTs to be built in her place. The keel of the first LST was laid down on the 10th of June 1942 at Newport News, Virginia, and the first standardized LSTs were floated out of the building dock in October. 23 were in commission by the end of 1942. The LST building program was unique in several respects. As soon as the basic design had been developed, Contracts were let and construction was commenced in quantity before the completion of a test vessel. Preliminary orders were rushed out verbally by telegrams, telephone, and airmail letters. The ordering of certain materials actually preceded the completion of design work. While many heavy equipment items, such as main propulsion machinery, were furnished directly by the Navy, the balance of the procurement was handled centrally by the Material Coordinating Agency, an adjunct of the Bureau of Ships, so that the numerous builders in the program would not have to bid against one another. Through vigorous follow-up action on materials ordered, the agency made possible the completion of construction schedules in record time. The need for LSTs was urgent, and the program enjoyed a high priority throughout the war, since most shipbuilding activities were located in coastal yards that were mainly used for construction of large, deep-draft ships. New construction facilities for the LSTs were established along inland waterways, some converted from heavy industry plants, such as steel fabrication yards. Shifting the vessels was complicated by bridges across waterways, many of which were modified by the Navy to permit passage. A dedicated Navy ferry command orchestrated the transportation of newly constructed ships to coastal ports for final fitting out. Of the 1,051 LSTs built during the war, 670 were supplied by 5 cornfield shipyards in the Middle West. Dravo Corporation's facility at Neville Island, Pennsylvania, designated the lead shipyard for the project, built 145 vessels and developed fabrication techniques that reduce construction time and costs at all of the LST shipyards. The Missouri Valley Bridge and Iron Co. built the most LSTs of any shipyard, with 171 constructed at Evansville, Indiana. Chicago Bridge and Iron's shipyard in Seneca, Illinois, launched 156 ships and was specifically chosen because of the reputation and skills, particularly in welding. The American Bridge Company in Ambridge, Pennsylvania, built 119 modifications. By 1943, the construction time for an LST had been reduced to 4 months. By the end of the war, this had been cut to 2 months. Considerable effort was expended to hold the ship's design constant, but by mid-1943, operating experience led to the incorporation of certain changes in the new ships. The LST 491 class replaced the elevator installed in the original LST-1 class to transfer equipment between the tank deck and the main deck, with a ramp that was hinged at the main deck. This allowed vehicles to be driven directly from the main deck onto the tank deck and then across the bow ramp to the beach causeway, speeding the process of disembarkation. Changes in the later LST 542 class included the addition of a navigation bridge, the installation of a water distillation plant with a capacity of 4,000 gallons per day, the removal of the tank deck ventilator tubes from the center section of the main deck, the strengthening of the main deck in order to carry a smaller landing craft tank, and an upgrade in armor and armament, with the addition of a 3-inch gun. LST Mk3 design. The LST design was successful and production extensive, but there was still a need for more LSTs for British operations. As such, it was decided to build a further 80 of the ships in the UK and Canada to be available in the spring of 1945. The British staff drew up their own specification, requiring that the ship be able to embark and disembark tanks, motor transport, etc., on beaches of varying slopes, and amphibians and D.D. Sherman tanks into deep water, carry 5 landing craft assault or similar craft, and 1 LCT or LCT on the upper deck in place of transport, and as an alternative to the LCT-2 and I causeway to be carried. The LCT and NI causeways to be capable of launching directly from the upper deck, to carry 500 tons of military load and to beach with that and sufficient fuel and stores for a 1,000 miles return journey at 10 knots, on drafts 4 feet 6 in forward and 11 feet 6 in aft, to carry a load of 60 tons over the main ramp and 10 tons over the vehicle ramp from the upper deck to the bow door. After trials, this was removed from some vessels, to be fitted for operations in the tropics and in cold climates. Two major problems made a redesign necessary. The preferred lightweight medium-speed electromotive diesel 12 to 567 diesel engines were not immediately available. Staff wanted more power and higher speeds if possible, which the EMD engines could have provided. However, the only engines available were very heavy steam reciprocating engines from frigates that had been cancelled. These delivered 2.5 times the power of the diesels. So large were they that significant changes had to be made to accommodate them. Lack of welded construction facilities meant that the hull had to be riveted. This combination of heavy hull and heavy engines meant that speed was only 3 knots faster than the LCT. At the same time, other improvements were made, as well as simplifications required, so most of the structure could be assembled with rivets. The cutaway hard chine that had been dropped in the American version of the Mark Chapter 2 vessels was restored. The tank deck, which was above the waterline, was made parallel to the keel. There was to be no round down to the upper deck, and the ship was enlarged to accommodate the more bulky machinery. Provision was made for carrying the British landing craft assault in gravity davits, instead of American assault craft. Provision was also made for carrying landing craft tank and landing craft mechanized, and NI pontoon causeways. When the design commenced, engineers knew that the beaches where the ships were expected to land would be very flat, but it was not possible to produce a satisfactory vessel with a 3 feet draft forward, and very little keel slope. So the 1 in 50 keel slope was maintained. It was known that the 150 slope would often result in the LST grounding aft on a shallow beach, resulting in the vehicles being discharged into comparatively deep water. Various methods had been investigated to overcome the problem, but heavy grounding kegs and the N.L. pontoon causeways were finally accepted as standard. The pontoon causeways were formed of pontoons 7 feet times 5 feet times 5 feet, made up into strings and rafts. When offloading, the rafts were secured to the forend of the ship, and the load discharged directly onto the shore, or towed on the raft to the shore. The ships were fitted out for service in both very cold and tropical conditions. The accommodation provided for both crew and army personnel was greatly improved compared with LSD. The main hazard, apart from enemy action, was fire on the tank deck. Fire sprinklers were provided, but the water drenching system installed in later American vessels could not be provided. The bow door arrangements were similar to the LSD, but the design arranged the bow ramp in 2 parts in an attempt to increase the number of beaches where direct discharge would be possible. The machinery for operating the bow doors and ramp were electrical, but otherwise, steam auxiliaries replaced the electrical gear on the LSD. The general arrangements of the tank deck were similar, but the design increased headroom and added a ramp to the top deck, as in later LSTs. Provision was made for carrying LCA on gravity davits instead of the American-built assault boats. The arrangements were generally an improvement over the LSD, but suffered from a deeper draft, and, to some extent, for the haste of construction. First orders were placed in December 1943-45 with British builders, and 35 with Canadian builders. Swan Hunter delivered the first ships in December 1944. During 1944, follow-up orders were placed in Canada for a further 36. These programs were in full swing when the war ended, but not all vessels were completed. The ships were numbered numbers LST 3001 to LST 3045 and LST-3501 to 3534. LST-3535 and later were cancelled. 15 40-ton tanks or 27 25-ton tanks could be carried on the tank deck with an additional 14 lorries on the weather deck. Propulsion steam was supplied by a pair of Admiralty pattern 3-drum water tube type boilers, working at 225 pounds per square inch. The main engines were of the 4-cylinder triple expansion 4-crank type, balanced on the Yarrow-Tweedy slick system, the cylinders being as follows. The common stroke was 30 inches. The piston and slide valve rods were all fitted with metallic packing to the stuffing boxes, and all pistons fitted with packing rings and springs. The high-pressure valve was of the piston type, whilst the remaining ones were of the balanced type. The main engines were designed to develop 2,750 horsepower at 185 revolutions per minute continuously. With the ships being twin-screw, the engines were fitted with a shaft coupling to the crankshaft at the forward end, allowing the engine to be turned end-to-end to suit either port of starboard side fitting. Modifications for landing craft. When the LSTs were ordered, the LST program was in full swing, and similar arrangements were made to enable the LSTs to carry the 112 feet long LCT-5 or LCT-6 that were being built in America for the Royal Navy. The LCT needed lifting onto the deck of the ship, being carried on wedge-shaped support blocks. At the time of launching, she was set down on the launchways by simply slacking off bolts in the wedge blocks, allowing the launchway to take the weight. To carry out a launch, the LST was simply heeled over about 11 degrees by careful flooding of tanks in the hull. The height of the drop was about 10 feet, and immediately after the launch the craft's engines were started and they were ready for operation. This method was used for moving LCT-5s from Britain to the Far East, although there seems to be no reference to LSTs being used, most being completed late in or after the war. Even at the end of the war there was a need for more ships able to carry minor landing craft, and 2 of the LSTs then completing were specially fitted to carry LCM. These craft, which were 58 feet long and weighed about 28 tons, were carried transversely on the upper deck of the ship. They were hoisted on by means of a specially fitted 30-ton derrick. This 30-ton derrick replaced a 15-ton derrick, 2 of which were the standard fit of the LST. The 30-ton derrick was taller and generally more substantial than the 15-ton one. The LCMs were landed on trolleys fitted with hydraulic jacks. These ran on rails down each side of the deck, and were hauled to and fro by means of winches. The stowage was filled from fore to aft as each craft was jacked down onto fixed cradles between the rails. The ships completed to this standard were LST-3043 HMS Messina and LST-3044 HMS Narvik. While these ships were able to carry LCMs, they were only able to carry out loading and unloading operations under nearly ideal weather conditions, and therefore could not be used for assault operations. They also lacked the facilities to maintain the landing craft. The landing craft assault were wooden-hulled vessels platted with armor, 41 feet 6 in long overall, 10 feet wide, and displacing 13 tons fully loaded. Draft was 2 feet 3 in, and normal load was 35 troops with 800 pounds of equipment. A pair of Scripps marine conversions of Ford V8 engines gave it speeds of 11 knots unloaded, 8 knots service speed, 3 knots on on one engine. Range was 50 to 80 miles on 64 gallons. Armament was typically a Bren light machine gun aft, with 2 Lewis guns in a port forward position. The LCMS that were carried on the LST were considerably larger, 60 feet 3 in length, 16 feet beam, with a hoisting weight of 28 tons, full load displacement of 63 tons. Beaching draft was 3 feet 8 in, and propulsion was provided by a pair of Hudson Invader petrol engines, later replaced with Gray's diesels, both sets providing 290 bhp, giving a speed of 9.8 knots. The main requirement of the design was to carry a 40-ton Churchill tanker bulldozer at 10 knots. 140 had been completed when the war ended, and some saw service through to the 1970s. Variants some LST were converted to LST by adding stiffening so they could safely carry the heaviest British tanks. 2 LST were converted to command vessels, LST 3043 and LST 3044. Post-war they became HMS Messina and HMS Narvik. They were better armed with 10 20mm Olicons and 4 40mm Bofors. 2 LST were converted during building into headquarters command ships LST. These were L3012, which became L3101, and LST 3013, which became LST 3102, and then HMS Ben Lomond. They acted as LST mother ships, similar in most aspects to American ships based on the LST hull. They had 2 Quonset huts erected on the main deck to accommodate 40 officers. Berths on the tank deck berthed an extra 196 men. A bake shop and 16 refrigeration boxes for fresh provisions augmented the facilities normally provided for the crew. 4 extra distilling units were added, and the ballast tanks were converted for the storage of fresh water. Service in World War II. At the Armor Training School in F.D. Knox, Kentucky, buildings were erected as exact mock-ups of an LST. Tank crews in training learned how to maneuver the vehicles onto, in and from an LST with these facilities. One of these buildings has been preserved at F.D. Knox for historic reasons and can still be seen. For the combat DE acute BUT in the Solomon Islands in June 1943 until the end of the hostilities in August 1945. The LSTs performed a vital service in World War II. They participated in the invasions of Sicily, Italy, Normandy, and southern France in the European theatre and were an essential element in the island-hopping campaigns in the Pacific that culminated in the liberation of the Philippines and the capture of Iwo Jima and Okinawa. Despite the large numbers produced, LSTs were a scarce commodity, and Churchill describes the difficulty in retaining sufficient LSTs in the Mediterranean for amphibious work in Italy, and later the logistics of moving large numbers to the eastern theaters, while still supplying the large armies in Europe. The LST proved to be a remarkably versatile ship. A number of them were converted to become landing craft repair ships. In this design, the bow ramp and doors were removed, and a bow was sealed. Derricks, booms, and winches were added to haul damaged landing craft on board for repairs, and blacksmith, machine, and electrical workshops were provided on the main deck and tank deck. 38 LSTs were converted to serve as small hospital ships and designated LSTH. They supplemented the many standard LSTs, which removed casualties from the beach after landing tanks and vehicles. LSTs had brought 41,035 wounded men back across the English Channel from Normandy by D-Day plus 114. Other LSTs, provided with extra cranes and handing gear, were used exclusively for replenishing ammunition. They possessed possessed a special advantage in this role, as the size permitted 2 or 3 LSTs to go simultaneously alongside an anchored battleship or cruiser to accomplish replenishment more rapidly than standard ammunition ships. 3 LST were converted into British fighter direction tenders, swapping the landing craft for motor launches and outfitted with Ames Type 11 and Type 15 fighter control radar to provide ground control, interception coverage for air defense of the D-Day landing areas. Of these ships, HMS FDT-216 was stationed off Omaha and Utah beaches. HMS FDT-217 was allocated Sword, Juno, and Gold beaches. HMS FDT-13 was used for coverage of the overall main shipping channel. In the period the 6th of June to the 26th of June, Allied fighters controlled by the FDTs resulted in the destruction of 52 enemy aircraft by day, and 24 enemy aircraft by night. In the latter stages of World War II, some LSTs were fitted with flight decks that could launch small observation planes during amphibious operations. These were US LST-16, US LST-337, US LST-386, US LST-525, LST-776, and US LST-906. 2 others were fitted with the Brody system for takeoff and landing. It has been estimated that, in the combined fleets assembled for the war on Japan, the tonnage of landing ships, excluding landing craft, would have exceeded 5 million tons, and nearly all built within 4 years. Throughout the war, LSTs demonstrated a remarkable capacity to absorb punishment and survive. Despite the sobriquets large slow target and large stationary target, which were applied to them by irreverent crew members, the LSTs suffered few losses in proportion to the number and the scope of their operations. The brilliantly conceived structural arrangement provided unusual strength and buoyancy. HMS LST-3002 was struck and holed in a post-war collision with the Victory ship and survived. Although the LST was considered a valuable target by the enemy, only 26 were lost due to enemy action, and a mere 13 were the victims of weather, reef, or accident. A total of 1,152 LSTs were contracted for in the Great Naval Building Program of World War II, but 101 were cancelled in the fall of 1942 because of shifting construction priorities. Of 1,051 actually constructed, 113 LSTs were transferred to Britain under the terms of Lend-Lease, and 4 more were turned over to the Greek Navy. Conversions to other ship types with different hull designations accounted for 116.